Okay, guys, the next thing I want to talk about with polynomial functions are the behavior at zeros, okay? So if you remember, if I look at f of x equals x squared, well, for one, we know what it looks like. In fact, we just looked at it in the last video. I know that I have this x and y intercept for that matter, but the key is that's an x-intercept, okay? Now, if I ask myself what the zeros of this is, the zeros, well, there's one zero. It's zero. Whatever I plug in for x that gives me zero should give me, should go ahead and give me zero, okay? And what I also say about this is, since this is squared, we say the multiplicity of this zero is 2, okay? The thing I want to point out here is, at that x-intercept, this thing is bouncing off of the x-axis and heading back up, okay? So just keep that in mind. Now, if I were to look at something like this, f of x equals x plus 2 times x minus 1 squared, okay? Now, if I'm going to draw the graph of this thing, okay? First of all, let's think about the end behavior, which we just talked about. What do you think the leading term for this would be? If you think it might end up being something like an x cubed, you'd be right if you were to multiply this all out. So I expect this thing to start low and for it to end high, like so, okay? Now, what do I have for zeros from this function? Well, I have zeros of -2, that comes from this factor, and I have a 0 of 1. This comes from this factor. The 2 has a multiplicity of 1, because this is raised to the first power, and the 1 has a multiplicity of 2, since it's raised to the second power, okay? Question is, what does that mean? Well, I know I have an x-intercept then at -2 comma 0, right there, and I also have one at 1 comma 0 here, okay? Now, I want to test a few points, okay? So first of all, I know I have to go up here and hit this. My question is this going to cross over or is it going to bounce? So let's pick a few values, okay? So if I pick x and f of x, and let's say I plug in -1, that should tell me if this is positive or negative here, okay? So if I plug that in into my function, then I should get -1 plus 2, which is 1, times -1 minus 1, that's -2, squared, okay? Now what that's going to be is something positive times something positive. It's just something positive. So I know this is going to cross, okay? And I could find my y-intercept if I wanted to, and that would be fine. This, in this case, it happens to be this point, 0, 2. Remember, y-intercept is just found by plugging in 0 for the x's. That's how I'm finding that, so that makes sense. Now I go down here, I know I have to hit this, and the question is that a cross or is it a bounce? Okay, well, let's see what happens maybe at this point when x is equal to, say, 2. So I use 2, I get 2 plus 2, that's something positive. 2 minus 1, that's something positive as well, especially when we square it. That's also going to be something positive. So can this cross? No, it has to bounce and stay positive, plus it'll match up with my end behavior here, okay? So what I want you to notice here is right here, I had the bounce, and here I just had a cross of the x-axis. The thing I want you to notice is with multiplicity 1, that corresponded to our cross, and with multiplicity 2, that corresponded to our bounce. So the pattern I want to point out here is with multiplicity 2, it looks like we're getting bounces at those x-intercepts, okay? When the multiplicity is 1, it looks like a cross. I wonder if this is an odd and even thing again, okay? So let's look at one more. I want to look at this one. X plus 1 to the 5th, okay? Now, think about your leading term. Your leading term is going to be x to the 5th, right? If we were to multiply this all out, that means we're going to start low and end high, okay? Now, I only have one 0, okay? I have a 0 of -1, and the multiplicity of that is 5. Okay? So I'll cross through here. This is fine, -1, 0. And I could also find my y-intercept. My y-intercept is actually 0, 1. Okay? That's just if we plug in 0 for x. So I know that this thing has to go through. This has to cross because it's the only x-intercept to get over to here. I know polynomial functions are nice, smooth, and continuous, so there's no asymptotes or anything weird like that. So I know it's got to go through, hit this, and then I know it's going to end high. Okay, I can take this one away because same thing is happening. That's fine. So something like that. But right here with multiplicity 5, notice we had another cross. I think this is a even odd type of situation. So let me get the rule to show you. Summed up, here's our rule for behavior at zeros. Okay? It says for a polynomial function, f of x having zeros of, notice I say odd multiplicity, the graph crosses the x-axis. That's cross. I mentioned here that the multiplicity greater than 1 wiggles as it crosses, like x cubed, but it's still a cross nonetheless. Even multiplicity, so squared to the 4th, if that's on our linear factors associated with those zeros or x-intercepts, the graph touches the x-axis or bounces is kind of how we were talking about it. Another interesting fact that may help you is that a polynomial function of degree n has at most n-1 turning points. And those turning points, if you think about it, that's when it goes from increasing to decreasing or decreasing to increasing. For example, f of x equal to x, that's when n is equal to 1, there's no turning points. F of x equal to x squared, n is equal to 2, 1 turning point, that is n-1. F of x equals x cubed, n equals 2, that actually has no turning points. But remember what it says, it has a function of degree n has at most n-1 turning points. It's at most. So it can have 0, or it can have less than n-1. So that's behavior at 0.